Hello and welcome to Some of My Nostalgia. We are looking at question 12 from IEB's paper 2022, paper 2 of November 2022. I'm having a bit of trauma flashback situations because the last time I did a similarity type question, I went on a very long tour, very long, arduous tour. So let's see if I can create better memories for myself here. Okay, triangle ABC is given with E. Okay, I'm just gonna follow with my little pointer. Triangle ABC is given with E and G on AB and D on AC, with AG equal to GB. Okay, AG equal to GB. Just gonna highlight those. Okay, right. And ED is parallel to GC. F is on CG and D on AC. You told us that. With DF parallel to AB. Okay, cool. Indicated by our lovely arrows there and there. Right, first task is to prove that CF over FG is equal to GE over EA. CF over FG is equal to GE over EA. So okay, I can see that there's a parallel line here dividing this triangle. So the ratio of this to this is going to be the same as the ratio of this to this. Okay, but then there's also this parallel line dividing this triangle. So the ratio of this to this is going to be the same as the ratio of this to this. So this guy is what is common. That is what is going to connect these two with these two. Okay, cool. So right, so we said AE over EG is equal to let me just use the same order as in the question, and also they have GE over EA, so this guy over this guy. Okay, so GE over EA, GE over EA is the same as DC over DA, because line parallel to third side of triangle AGC. Okay, maybe let me name my line so that the examiner knows what I'm looking at. So I'm looking at this line, right? It's gonna split this side and this side in the same ratio. So that is line ED. Okay, right. But then I also know that this line is going to split this side and this side in the same ratio. So CF over FG is also equal to, so CF over FG is also equal to CD over DA. Let me keep with my order from here so that it's clear, right? Is also going to be equal to DC over DA. And this time we're looking at the line DF parallel to third side of the same triangle, triangle AGC, right? And so because those are both equal to the same thing, that tells us that GE over EA is equal to CF over FG as required to show. Okay, right. And forward we go. So bearing in mind, as highlighted previously, we were told AG is equal to BG. Okay, and we've also now discovered that the ratio of this to this is the same as what was it again? Okay, so GE to EA, so the ratio of this to this is the same as the ratio of this to this. It's the same as the ratio of this to this. Something like that. How can I indicate that for myself? I just put little knobs. So AE, GE, GE to EA is the same as CF to FG. Oops. Even though it doesn't look like it. Oh, that's because I've swapped them around. Sorry. GE to EA is the same as CF to FG. Okay, and we also showed that those are the same as DC to DA. So DC to DA. Okay, right, so that's how I'm going to remember that these are all in the same ratio. Right, so we are now told, if CF to FG is 2 to 1, so this is double this one, this is double that one, this is double this one, determine the ratio of GE to GA. So this is 2 parts, this is 1 part, so this would be 3 parts. So the ratio would be 2 parts to the whole, which is 3 parts. Right, so we know that GE to EA is equal to CF to FG, proven in previous question, and that is 2 to 1, which is now given to us. So therefore the ratio of GE to GA will be equal to 2 parts to 2 plus 1 parts, which is 2 to 3. Right. Okay, now I have to do my beautiful drawing again. Just going to copy paste. That's what's up. Ooh, see what? Hey, ooh, girl, you know what's up. Okay, so we now know that the pinkies, the purplies, to the greenies is equal to 2 to 1, which we were given in the previous part of the question. Okay, cool. determine the numerical value of df to AB. So Amina. So if we look at what's going on in this system, right, we know that, okay, this triangle is similar to this larger triangle, right? And the similarity factor is, or it's a similarity ratio, I don't know how you say it, is 2 to 3, right? Because these sides represent 2 parts, and then this whole side would represent 3 parts, right? So the ratios we're dealing with here is 2 to 3. Okay, so the ratio between this side and this side is 2 to 3. But now we know that GB is the same length as AG. So if this is 3 parts, then this whole side would be 6 parts. So the ratio of DF to AB would be 2 parts to 6 parts. In other words, if DF is 10 units long, yes, is 10 a good, yeah, okay. If DF is 10 units long, right, then that means this is 15 units long, right? And that means that this is also 15, which means this whole thing is 30. So the ratio would be 10 to 30, which is 1 to 3. Okay, now how do we write all of that in a manner? So I feel like I have to show that these are similar so that I can show that these two exist in the ratio 2 to 3. And then from there we can bring BG into the question. I don't know if I have to do this. I'll see in the memo, but yeah, in triangles DFC and triangle CAG, we have angle C is common. We have angle FDC is equal to angle A because of corresponding angles on the parallel lines FD and AG. And then we have angle DFC is equal to angle AGC for the same reason. Right, and therefore triangle CU. Saying one letter and writing another one is madness, not congruent. Similar to triangle CAG, because angle. So let's just see if this tracks. So C and C, yes, they're common. D and A, D and A, F and G, cool. Right, and so therefore CD, okay, let me not just shoot aimlessly here. Let's target what we already have. Right, so from this question, we figured out the ratio of GE to GA. Oh, did I look at the wrong thing? Okay, but yeah, it's fine. So we have GE to EA. Which also gives us the ratio of I mean either this or, yeah, it's fine. So let's use this because I mean it's given to us. So I'll try to get a ratio that includes CF and CG. Okay, so that is CF and CG, and then the one that I want to be included as well is the DF and the GA. Right, so the similarity tells us that DF to GA is the same as CF to CG, and that's because of the similarity of these triangles. Okay, and we know that the ratio of CF to CG is 2 to 3, the same as GE to GA. So CF to CG will be 2 over 3. And that will be the ratio of DF to GA. Okay, then we also know that the ratio of GA to GB is equal to 1 to 1. We were given that they are equal, right? And what we are interested in is no. So actually I don't care about GB. Okay, I care about AB because that's where we're trying to get in the question. So the ratio of GA to AB is 2, right? We give it 1 to 2 because we're given that's given to us subtly. We're told that these two are equal, so the ratio of this side to the whole of this side is going to be 1 to 2, right? If this whole side is 10, then we know that this is 5. Or if this whole side is 100, then we know that this side is 50. Okay, and now I want to rewrite my ratios so that this guy over here, that represents the GA, is the same number over here, so that from there we can compare this number to this number directly. Right now we can't because GA is represented by 3 parts here, and in this equality it's represented by 1 part. So we are going to rewrite this as, no, we don't need to rewrite that one, that's fine. We can rewrite this one as 3 over 6. Same ratio, same fraction, right? But now the key thing is that we are able to say, well, the ratio between DF and GA is 2 to 3. The ratio of GA to AB is 3 to 6. So the ratio of DF to AB is going to be 2 to 6. Right. So DF to AB will be equal to 2 to 6, which is the same as 1 to 3. Right. Let's see what the memo thinks of our valiant efforts. Hey, these calculations are confusing my brain, man. Now, yeah, I'm not invested. I'm gonna park it here. Cool. Catch you another time for another chat.